Detailed instructions for using our software and sensor. Make sure the appropriate PP is on hand before starting. The sensor should be at room temperature before proceeding. Start by first examining the external sensor for any signs of physical damage. Cosmetic damage may indicate rough handling of the sensor, such as dropping, but may not always mean that the sensor is not working. If there is, you may take a picture of the damage and send it to us if the sensor is not performing well. Position the USB side of the sensor facing upwards to avoid damaging the sensor in an event that there is a leak. To prevent leakage and damage to the tubing, insert the tubing by first inserting the ferrule all the way in. Ensure that it is secure. Do not force the tube connection into the sensor, as this may damage the ferrule connection. Once the ferrule is secure, slowly screw in the nut. Position the nut properly so no cross-threading will occur. When the tubing has been securely connected, ensure that it is tightened properly so no leakage will occur. It should be finger-tight like this. If you over-tightened or have damaged ferrule, it will look like this. The ferrule and the tube will not align properly, as well as the yellow part of the ferrule scraping off. An undamaged ferrule will look like this. The ferrule and the tube will align properly at the end. There is also no visible damage on the yellow part of the ferrule. Placing them side by side, you can see the difference between a damaged and undamaged ferrule. Once the tubes have been connected, attach the USB cable to the sensor. A small green light will indicate that it is plugged in. On the software screen, click the Connect button. This will start the warming up of the sensor. Before beginning any sample measurements, make sure the sensor is plugged in and connected for at least an hour, but if possible, for 2 hours to obtain the best and most accurate results. Proper way to do manual sample injection. Before the sample is injected, ensure that there are no air bubbles in the syringe. If there are air bubbles, push out the bubbles first and then proceed to push in the liquid. Make sure the syringe has a filter at the end so the sample may pass through. To stop contaminants or impurities from getting inside the sensor and possibly clogging it, filter every sample that passes through it. Using a waste bottle setup. The outlet tube will be directly connected to the waste bottle. Slowly inject the sample into the sensor through the filter. Ensure that the air bubbles fully pass through the sensor. The tubing should be full of liquid, and no visible air bubbles should be present. Having air bubbles will result in inaccurate measurements. Do not force the injection if there is a big resistance, as this will cause pressure to build up and may result in cracking of the sensor. Settings and starting of measurements. Before starting of measurement, edit the measurement settings. You can refer to the user manual for suggested averaging and number of files. Key in your sample and operator name. Remember to tick all the boxes from current to P8 to see the change in spectra. Once your sample has been injected, you may begin starting of measurement. Setting up background. Take note to change the instrument setting for the number of files for the background, as this will affect how it is scanned and the duration of the background scan. While background is being scanned, do not start measurements in the Measurement tab. To set a new background, go to the Validation tab and click on Scan New Background. You can either use air as a background or your desired solvent of choice. You may also use factory background as a start and run measurement. Remember to select the correct background file before performing measurements. Once the background scan has been completed, you'll be able to see the new background, factory background, and the selected background on the graph. The drop-down menu becomes editable after new background is scanned. After keying in the new name and clicking Save New Background. Once the background has been saved, the new background file will appear in the drop-down menu. You may then select your desired background here. You can also choose to save and use the new background by clicking on Save New Background. Upon clicking, a pop-up message will appear, and upon clicking Yes, will the currently selected background be saved with this new background. Take note that using this method will override the previous file saved. Guide to cleaning the sensor. Prepare 10 milliliters of toluene with a syringe filter or another cleaning solvent of your choice that can effectively clean the sensor. Do this for isopropyl alcohol as well. Using isopropyl alcohol accelerates the drying process. Inject toluene through the filter and into the sensor slowly. After injecting toluene, inject isopropyl alcohol through the sensor slowly. Prepare an empty syringe and clean filter to push air into the sensor. This is to speed up the drying process. Push a minimum of 3 times. If there is still liquid in the sensor, push air again. Another way to ensure the sensor is dry is to use a vacuum pump and desiccant to purge the sensor for at least 10 minutes. Guide to troubleshooting a clogged sensor. In the event of injection, if there is resistance when the sample is being introduced, do not forcefully push the sample through. Resistance of the sensor may be due to clogging or cracking of the sensor. If there is resistance, stop measurement and push out the remaining liquid slowly without applying too much force. Push in a solvent you know that would dissolve the previous samples and soak it in for at least 30 minutes or longer. If using acetone or halogenated solvent, avoid soaking for more than 1 hour. After soaking, push out the liquid. Inject in IPA and soak for at least 30 minutes or longer. Using a cleaning solvent may dissolve the residue and unclog the sensor. Push air to check if there is still resistance. If there is still resistance, contact us.